I want to do a very quick video on the censorship assumptions that will allow us to do standardization very simply as we did in the last video. So what do we need to do in order to prove that we can do the standardization without worrying too much about censorship? So we would need to prove exchangeability, 1. So this would show that y under the condition of c equals 0, which could be death, it could be working at this particular location, and the causal effect would equal the causal effect under the case where where c equals 1. So the average causal effect as measured under the case where c is conditioned to be equal 1. If this is true, then we have exchangeability. If this isn't true, we need to do a lot more in order to get at the actual average causal effect of the total population. But, as always, sometimes we're just interested in c equals 0. So sometimes we're interested in just the patients that survive. Okay, the next two assumptions should be very quick. One is positivity. So this one says, hey, within our c equals 0 case, we need to have both patients that are treated and patients that are untreated. We need to have all sorts of treatment values in that c equals 0 case and in the c equals 1 case. If we don't have that, we can't compute the actual causal effect. And then finally, SUTFA, the stable unit treatment value assumption. So this is pretty important. You need to have a well-defined censorship. So this needs to be well-defined, so death is fairly well-defined. Maybe working at the location might not be well-defined. Perhaps someone's taking a vacation. In addition to that, you also need non-interference. So you need that when people are assigned the censorship value 0, they don't necessarily affect the other treatment or treatments of other people around them. Okay, so as long as we have these assumptions, positivity and SUTFA are generally easy, exchangeability is the hard one to sort of prove, we can go ahead and we can ignore, in effect, censorship. That being said, there are other tools that we'll talk about later on, particularly instrumental variable analysis, that will allow us to get around these assumptions.